Pebbles? All right, so
You haven't been slacking on that gong lately?
hey, you have been slacking on the gong.
Sorry about that. I'll come prepared next.
I did make fun of you in class yesterday. I was showing a picture of how
Who?
you,
Me?
the way you were sleeping at the.
When? Oh, I was like eating my food and sleeping?
No, last night to your house.
What?
I'm just creeping on everybody. No, at the hackathon, when you were sitting there, I took a picture. You were like all bundled up, and like 20 seconds later, you just folded in half on your lap for like an hour.
For an hour?
It seemed like a while. You were out.
When was this? I don't even remember that. Yeah, let's see this picture.
Yeah, I kind of want to as well. I don't know what you're talking about.
I didn't know a human being could like fold like that. Right after, yeah. So I had this picture of you, and you look kind of deranged in it, like something's not right.
All right.
And he's wearing like all of these like. Doesn't he kind of look like an old woman there?
I do remember that.
Yeah, I
And
remember
this
you
is
making
like
that
30
comment.
seconds later.
Oh.
Oh, I was
just
reaching
laying on
down
the
to get
table.
something.
You were in that position for a while.
I see that.
The time where you almost fell asleep eating breakfast, that was funny.
Oh, yeah.
He had a piece of toast or
Waffle
whatever,
on that.
waffle in your hand, and you just like fell asleep.
That was at the hackathon.
Yeah, while eating my waffles and chicken.
So it's so really you think you may have actually fallen asleep while reaching down to pick something up.
I guess that's possible.
You reached down to pick it up.
I can't deny
Fell
it.
asleep. Woke up, picked it up, and thought he had done it all in like 3 seconds.
All right, so we're starting up our nitrous box. I assume everybody who wasn't here last time watched the video.
Definitely.
I'm sure.
All right, so why don't you explain to me what nitrous box is, Abe?
It's a online IDE from a web browser. If you Node.js.
You did watch it.
No, he didn't.
How much of it did you just read?
I didn't read anything.
All right.
You were asking beforehand.
All right. So last time we created a little Hello World server with Node.js. So remember at the top here we have our Express, which is actually the name of the web server module we were using. We created an instance of Express here. Then we started creating some endpoints. In this case, we only create one endpoint. The endpoint's called get, and the endpoint's going to be at the slash. And we have a function, request response, and this is actually embedded. This guy right here is called a closure. That, what I have highlighted there is in programming languages, it's a term called a closure. It's a function embedded as a parameter to a function. So this app.get function takes two parameters. It takes the endpoint, so in this case slash, and the second parameter is a function.
It's set up as a normal function, right?
Who?
Like the syntax is pretty much a normal function.
Yes. Yeah, it just happens to take a function as its second parameter. That is, what should happen when this endpoint is called with a GET request? This is what should happen, whatever this function has in it. Make sense? All right, and we went ahead and we ran this last time. Okay, it's sitting there listening, and then in order for this to work, since technically Nitrous is a hosted virtual machine up in the cloud that happens to have an IDE running on there and happens to have Node installed, we have to, in order to view it locally, we need to go in here and say preview, and we're looking at port 8080 was the port we used here. And it goes ahead and figures out what our current IP address domain name is up here, so we get something that looks like that. Okay, so this is our actual server in the cloud. All right, so let's go back over here. So we were in our hello server thing here, and this is what we wrote. Okay, so now here's some examples of making this a little bit more complex. So I'm actually just going to steal this line here, and we'll go over to nitrous. I'll paste in the second thing here. Close this chat. Okay, and I'm actually going to also guess we can't go any farther. All right, so now we added a second endpoint. Now we did talk last time, if I remember correctly, about RESTful APIs a little bit. Is that correct? In terms of get, post, put. Hey, what's CRUD?
Crud.
CRUD.
It's the stuff on the bottom of your sheet.
Tim? Tim was here last time. Let's see who's got CRUD. Tell me everything you know about CRUD. Amish?
I didn't watch the video.
Brazil? It's CRUD.
For a basic operation. Create, read, update, and create, update, read, and what
The one that starts with a D.
delete. Delete.
Huh?
It distracted me.
Did he? You didn't know that, did you?
I did.
Okay, all right. So in any case, we talked about that last time. So we have the ability, so when we do a GET request here, if we are implementing a RESTful API with this, we're probably responding to somebody who wants to retrieve something from the database. Okay? So in this case, notice this endpoint that they're creating. We have a slash first name slash last name with some colons in there. Again, same kind of closure, request, response. And notice that this guy's taking in a first name and a last name. This special syntax that they've given here is what's going to be required of us to test this. Okay, and we can see what a get is going to look like. So this allows us to, from the request, get the parameters for first name, and from the request, get the parameters for the last name. And then we're going to respond by saying hello, whatever your first and last name is, and then we're joining on spaces. It's just a JavaScript function. This just concatenates hello with the space, with first, with the space, with last. That's all that's doing. So I'll go ahead and save that. And we're going to go ahead and hit the endpoint first and last. We are already in a web browser. One of the downsides of working in a web browser is coding in a web browser is already in the web browser when you want to go and do something. So now I can say /Mike /Littman. Rutro. Oh, I gotta start it again here. This guy saved, yes. I don't think I have to restart it every time. Huh, I do. All right, so notice that the endpoints was /Mike /Littman, and it determined that here were your two inputs. That make sense? So we can build RESTful API endpoints in this way. So for instance, if we want to have something that goes in, I'm going to get it one of these days. Think? So let's modify this one. We're going to say this is /add. Actually, I want to do it that way because we never use it that way in Restful. I'm not going to do it that way. All right, so in any case, a more advanced endpoint, still have our closure. We see how we can request things from the endpoint. All right, now we deal with echo servers. So this is where we start getting into JSON. So let's go ahead and steal this code. Okay, we've got our server, we have our single endpoint, and we're going to respond with some JSON. And the JSON we're going to respond with is opening curly brace, name value pair, comma, another name value pair. Okay, so now when I run this, no, I really didn't think I had to restart the server. I'm going to try this here. Might be a nitrous thing. Yeah, you do have to restart the server. All right, so here's our JSON that came out here. What could you tell me about JSON in terms of being a data representation language? What does this guy look a lot like? If you had to describe JSON to me, what might you say in terms of data structures? How many of you have heard of a dictionary? You haven't heard of a dictionary, Abe. No way. This is brought to you by the mind that brought us iDump.
It's a good idea.
It was a good idea.
We needed that at one point.
We needed that at 4:30 in the morning. That's serious. We searched for bathrooms.
Yeah, I heard there was some poor decision making where at 4 in the morning you guys were looking for bathrooms. You decided the smart thing to do was to walk a mile to a McDonald's when you had 3 perfectly good cars that could transport you to McDonald's significantly quicker.
Yeah, but we thought we could just walk somewhere like close. By, and
Okay.
then it was like, well, let's keep walking, not walk back to the car, then drive to
So in retrospect,
Well, a big thing was too. They were blocking off that parking later in the day. Morning.
So anyways, dictionary is a list of keys, that's a key, and definitions, keys and values, okay? Just like you look up in a normal dictionary, you look up a word, you get its definition. Key value pairs, okay? So JSON is made up of those. It also supports arrays, but we're not dealing with that right now. All right, so this is what our output from this guy was. All right. Let's actually do something up here real quick. So let's go ahead and make this guy an echo server, similar to what we did before. So the echo server is going to take in a string to echo, correct? And then we're going to just respond back with whatever we read in. Go steal some of our text from up here real quick. Since we don't have auto completion stuff. So we're going to say response.send request.params.string. So whatever we receive up here, we'll send right back. So this is a client-server model, all self-contained within the Node server. Kill this, restart it. So we'll say blah, there's blah. We'll say woot, there's woot, so on and so forth. Okay? Now, these functions here, request and response headers, can do several different things. So let's go and look at node response object. Look at the documentation for that. Let's see. So this is Node.js.org, the website, and it has documentation listed here. And we're going to look at Express. Click the HTTP guy here. Okay, so as an example, notice we can get the socket associated with this, so we can do all that kind of stuff, the same kind of stuff we did in Java. Let's do Node.js Express documentation, because we want specific stuff that that guy can do. So it doesn't come with Express, it's part of the... Well, here's a couple things we can do with it. We can do base URL, so let's experiment with some of these things. So I'm going to go ahead and respond with request dot base URL. Make sure so that's this guy right here, base URL. Save this. Start it. We'll go ahead and run this again, and it should give us the blah nitrousbox.com as our base URL, I would think.
Don't you get rid of loop?
No, because we still have the same endpoint. It's still the endpoint that takes in a string. Let's send request.base URL. Is it just the empty string in this? I mean, I think it is printing, it's just the empty string. So it doesn't know about the base URL if it's coming from a browser. Well, let's look at request body then. Save that, kill it, start it. Oh, we gotta be doing something wrong here. We need to get the individual pieces of it. Request.base URL. All right, well, host name should definitely work. If this doesn't work, then we're going back to just echoing something because we've broken something. There we go. So here's host name. So it tells us where this guy came from. So we can extract that from the request. We can get the specific IP address. Original URLs. Here's the params. We've already messed with that. We can get the path. And let me show you that real quick because that's actually going to be beneficial for us. Let's go back to the first /last. Then do request path. Kill the server, start the server. So it showed us that the path is whatever was typed in, whatever was after the slash up here. So notice that we didn't do anything having to do with first and last in our code in here. Path was our way of knowing what endpoint the person called. All right, we can use that for different things too in a RESTful API. We'll see that later. All right, let's look at our response. Things we can do with our response. We can append stuff onto our response. So let's see how that might work. I would do a couple of interesting things with that actually. Let's write a little for loop. For var I is equal to 0, I is less than 10, I plus plus, we can go ahead and say response dot append I. So each time through we're actually writing something extra to our server, and actually we'll go ahead and concatenate onto that a \n just to kick it down the line. All right, so we're actually writing to our response multiple times here instead of creating a single string and writing it out. Save it, kill it, start it. All right, so it's still waiting. Is it blocking? Remember when we did flush with our Java sockets? I've appended a bunch of stuff to this, but I haven't actually probably even have a flush in here. So it looks like I'll just have to do a single write. Respond. Oops, let's do it after the loop.
Would have been called something else.
Send.
Huh?
Isn't it send?
Oh, send. Yeah, thank you. So send does an auto flush. Brought to you by iDump. Save that. Start that. Finders.
Back to the documentation.
Let me go to append. Append should let us, if we don't give it a first parameter, it should just put it into the body, unless we have to specify we're sending it in the body.
So it requires a string or an array.
We're given it the string already. I just have to give it the header for body. And then that guy will boil down to a string. Apparently not.
You don't need semicolons.
What do you mean I don't need
Go
semicolon?
back to your code. Aren't you missing after
Oh,
and after
I thought you were saying that.
after send?
Yeah, I've been writing Swift all day.
Semicolon.
No semicolons in Swift.
Wow. Do you use anything?
You don't even write text. You just sit there and stare at the screen. It's a new thing.
How do you think we did so well with that?
Is that your is that what you based your visual programming language on? Just staring at the screen?
This is indenting very funny.
This is the base for the first ever one of those things where you just think it and the computer does it. So totally.
I'm just gonna write this out to the server because this is indenting really funny with the closure. Just want to make sure we're dealing with code that works before we keep changing stuff. All right, so it sent one thing, which is fine. The other thing should not have shown up. Send, we would have to have built it up. So we could have say string answer is equal to the empty string, and then say answer
And then it's still just var.
plus equals, it is. That was Java. Answer plus equals I.
Now I need to fit in Objective C
And
C
then-
sharp.
And then response dot send answer after the loop.
Is it loosely typed language?
It looks like a loosely typed language, but actually is a strongly typed language. Swift. Yeah.
I think
This would work as a variable definition in Swift. If you weren't going to set it right off the bat, you could say var answer string, like that. Or if you didn't even want to give it a type, you could just say var answer like that with the question mark. And that's called an optional, where you can fill it in later.
I know I need this variable, but I'm not sure what exactly it's going to do.
Right.
Does it let you use semicolons, or does it get mad at you?
Gets mad at you. All right, so there's all our numbers. So we can only do a single send, but we should be able to build up one character at a time, and that's what I was doing with the append. All right, kind of unimportant for what we're doing right now. Okay, so that's our endpoints. Kind of fly through this a little bit. Yep, so we did the response stuff. Okay, well, so this one, now we can write clients in the node that will actually go and do something else for us. So we need to install this thing called UniRest, which is for RESTful APIs. So we'll go back out, go in here, out to the console, install -- save UNI rest. Okay, while that's grabbing all that stuff, we'll keep looking here. So in this case, we're going to create an instance of UniRest. We're going to use this guy to get from a certain URL. And on completion, these are events. We're starting to talk about this asynchronous communication starting right here, and I'll kind of walk us through it when we do this. Oh, that guy's, there we go. Okay, so now instead of us creating a server that listens, we're now creating something that uses Node to connect to something else. So I'll go back here. So here's our UniRest. Here's the place we're going to connect to, this guy, which could have just as easily been the guy we just wrote. Okay, our own server. And when we finish, so after this connection has happened, when we finish, we can respond. We'll get a response object. And we're going to just write some stuff out to the console. So I'll write the status code, the headers, and the body from the response. This will be interesting because response.body didn't work for us before. Probably because we weren't actually getting anything. We didn't build that on that end. That's fine. So we're going to go ahead and run this again. It's actually not a server anymore. Now it's something that just runs here from the command line. Okay, so big web page here that just shows us a whole bunch of crap. I'll show you some Unix commands here. So this is putting out the status, the headers, and the body. Let's actually, just for right now, have it not do the body. The body is the one that's did I save that? No, I hadn't saved it. There we go. A little bit more digestible. So here's our servers. Content type we got, blah, blah, blah. Okay, so this is just reading stuff from the response. The body was everything that was on that web page. Is there something funny?
Well, I mean, the server's called Unicorn.
Unicorn. Oh, so it must be a. It's actually a Node. I think it's a Node.js server. That is from the GNU open source.
Oh. And then there's the Hello Human header near the bottom.
Oh, hello human. Okay, so now this is how we can talk to another server using this guy. And this end thing gets called as soon as that event finished. But there's different events that we can respond to in there. And we'll see this. So this is part of what we're looking at with Node, which is called asynchronous communication. Let me actually just write something about that here real quick. Asynchronous communication allows the client or server to be notified when a certain event occurs and respond accordingly. So if we think about this in terms of our Java client-server model we had, where we kind of had these threads that were constantly saying, is there a new byte, 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 or another guy saying, I need byte 8, I need byte 9, I need byte 10, so on and so forth. Instead, this guy just sits there and he becomes notified when somebody else wants a byte. So using our little example, if this was Tim's file, who was the source of the file, and Abe requested byte number 8, Tim wasn't constantly checking. Tim didn't have this thread that was constantly checking for a request for something from Abe. Because Abe may never send that. That's just a big waste of time, right? That's like sitting by the phone, waiting for it to ring and just checking every, thousandth of a second or something like that. So in this case, Tim's just minding his own business, not even interested in whether the phone goes off. He's not even paying attention, is what is happening. So what are we doing on the laptop today? Is it really notes? Really? I thought it was YouTube or something. I was sure.
I
had
was playing Reddit PC Master Race.
I had no faith. No faith. What was I talking about? So instead of you constantly checking to see if there was a request for a byte, you're just sitting there minding your own business, doing nothing until somebody alerts you that a byte has been requested. And that's what happens when Abe makes the actual request for a byte. Then an alert is sent to you, and then you asynchronously decide, okay, I'm going to join this conversation, and I'm going to serve the byte. Make sense? So asynchronous communication is actually more efficient for this type of thing. But asynchronous communication has been around for a really long time. It's not like it's something that just came out yesterday. We just started applying it to new kinds of problems more recently. Why do you think asynchronous communication hasn't been something that we've used as a replacement for threads up to this point? What's the role of a thread, or what do you suspect the role of a thread originally was? So this kind of comes down to almost an abuse of intent. Why did we need threads in the early days? To simulate multitasking, to have more than one thing seemingly happen at the same time, to prevent a function from blocking, that kind of stuff, right? So we would spawn off multiple threads so that things that could potentially happen concurrently could happen seemingly concurrently, using as many system resources as were available or as the operating system was willing to give you. But then we started using it for other tasks. That is, we've written threads in here that just constantly do something over and over again. Check on something, check on something, check on something. Threads were never meant for that. Threads were meant to perform a task until that task is done and then die. Okay? That's what a thread was meant to do. Even in a situation where you're constantly handling a task, So for instance, the example we used originally for threads is like authentication. So somebody puts their username and password in, hits send, or hits login. It goes to Amazon's web server, which that point is an asynchronous call, right? Well, actually, with Java threads, it wouldn't be. It's still synchronous. He's sitting there waiting for the phone to ring. So it's not asynchronous. He wouldn't be sitting there doing nothing. He would be sitting there. Phone rings, boom! Spawn thread, hand it off. Wait for the phone to ring again. Boom! I went too fast for you there. You probably didn't even see that move. I did that. It was 3 different clients that came in. You maybe only saw one. It was a blur. Right, old Alex?
It's almost as fast as you were running for that battle hack
I know.
down the street.
It was so good. Okay, so asynchronous communication really steps in to solve part of the problem that we've been solving another way, and we've really been solving it in a poor way, using threads to constantly check on stuff. Okay, even that situation with the server. We have that the Amazon's web server. Is it a good use of system resources for it to sit there and wait by the phone? Just wait for somebody to request www.amazon.com? Is that a good use of system resources? Is it a good use of your time to hang out by your door just in case a package arrives? No, not a really good use of your time. Could you argue maybe it's a better use of Amazon's time since they're very likely going to have a connection in a very short period of time? You could more easily make the argument in that case, correct? You're better off being ready because the Amazon model, response time is important. So you don't want to have the phone ring and then somebody picks up and goes, hello? And they've asked for Amazon, and then you scream down the street to Amazon, who's out there. They followed a lead from iDump, and it was somebody wrote it was one of those fake posts. It wasn't even a bathroom there. It was terrible.
I tried to mark a tree before our presentation.
Did you really?
Yeah, it wasn't working outside though. It was only working inside.
That makes sense.
Doesn't, because it wasn't on Wi-Fi either place.
And it wasn't plugged into my computer when I was inside and making pins.
So it made absolutely no sense. It's weird.
I don't know, maybe I didn't have good signal outside, I guess.
Are you using location services?
Yeah.
Okay. So in any case, asynchronous communication steps in to handle those situations where we can have somebody in the other room who just situationally needs to deal with things. Okay? And where we see asynchronous communication in this particular case, we kind of see both examples that we've just talked about, is we see this .end event. This is an example of asynchronous communication. This guy is going to go ahead and connect to the server. Done. It's going to connect to that server. Only when that connection has finished will he execute this function. And so this function actually occurs when this event is raised. So it's like you're sitting there minding your own business and you hear somebody shout down the street. That catches your attention. That make sense? And then you respond accordingly. Okay, by going back to playing your video games. Okay, so what we're going to do next time is we're going to look at additional events that we can respond to. These are additional entry points into the Restful API lifecycle so that when people make requests, we can respond differently. And then what we can do is start building up our server so that we can have requests made for bytes and requests for sending bytes, so responses for sending bytes happening simultaneously because they're all happening asynchronously. Okay? I'll see everybody on Friday.